Johnson's rule schedules work between two workstations. You can tell that this scenario is a Johnson's rule problem, even if it didn't say so across the top in the book. Here, I'll show you what I mean. The cargo manager of Global Freightways Edinburgh Center is concerned that the analysis of the 5 courier jets in scenarios 1A and 1B does not recognize the total time each courier jet requires, that is split between two phases, loading and unloading of the jet. Now, what I just underlined right there is what I mean. You can tell that this is a Johnson's rule problem. Even if it didn't say so in the book, the fact that they're talking about a couple different things that need to be done, that's these jets, and that, well, wait a minute, suddenly there's 2 phases to the work on each thing, unloading and then loading, it has turned into a Johnson's rule problem. Now, the good news is that the Johnson's rule is actually fairly easy to implement, but we'd better take a look at the data. Okay, so we have 5 jets that each need to be unloaded and then loaded again. One crew unloads a jet while another crew loads a previously unloaded jet. A detail missing from the earlier analysis, right? This is again what is turning this into from a simple priority scheduling problem to a Johnson's rule problem. This is done, the unloading, and then this is done, the loading. So great. What's the question? How should the cargo manager schedule the 5 jets to minimize the total amount of time required to accomplish all loading and unloading? Why did I underline that? That is another giveaway that this is a Johnson's rule problem. Johnson's rule, if you follow it, finds you the schedule that, good vocabulary term, minimizes the make span. That's what I'm writing there. Minimizes the make span of a schedule, or the total amount of time it takes to get all the work done. What was asked for here, minimizes the total amount of time required to accomplish all loading and unloading, is the same thing as saying, please minimize the make span of the schedule for the 5 jets. Oh, okay, so we just need to employ Johnson's rule. Now notice that really at this point, the only thing that we need to do into creating a schedule is decide in what order to work on the jets. With Johnson's rule, if you don't happen to have, for instance, this note frame, you're working on any problem, the first thing you do is you should make yourself a worksheet. Just like you see here. It says Edinburgh Satellite Center sequence, and see how there is just 5 blanks? There are 5 jets to be scheduled. Make yourself a worksheet with 5 blanks. Who's going to be first? Haven't decided that yet. Who's going to be second? Who's going to be third through 5th? Okay, once you have that, and you have that if you have the note frame, it's time for Johnson's rule. Think of Johnson's rule as the find the smallest number rule. Because here's how Johnson's rule works. Look at your original data. Now, something that's kind of sneaky about this scenario is when I say look at your original data, in the original scenario, it tells us the original total amount of work that needs to be done on each jet, right? The total duration. That's not the data that we're talking about. That's kind of sneaky. That data here was split into loading and unloading. In order to use Johnson's rule, that's the only numbers you want to be looking at. The loading and unloading. The work at each one of the 2 phases, whatever the 2 phases are in the problem. All right, you say, well, fine, what am I supposed to do? Find the smallest number. That's it. Look at the data that you're given. That would be this right here. And find the smallest number. Oh, okay, well, I'm looking here and let's see, the smallest number looks to me to be a 0.1, right? A 0.1, fine. Don't lose track of it. It's right here. Okay, what's that mean? It means, first off, who does the 0.1 belong to? Well, it belongs to Birmingham. It refers to the Birmingham jet. Okay, it's time to schedule Birmingham. All right, fine. Where should I schedule Birmingham? If, this is Johnson's rule, if the smallest number that you found occurs at the first workstation, the first department, the first phase, schedule that job first. If it occurs at the second workstation, the second department, the second phase, the second column in your data, schedule that job last. All right. Well, in the case of Birmingham, it's in the second column. It's referring to the second thing that's done. Great. That means this job, or I should say this jet, in the case of this problem, the Birmingham flight, goes in last place. Work on that jet last. All right. What's next? Mark that jet off the list. Lightly, I would suggest, in most cases, to be practical. But don't want to be distracted. Marked off the list, meaning I'm just not going to look at that row anymore. Fine. Then what? Same thing. Smallest number. Now that that's marked off the list, where's the smallest number? Smallest number of who's left? Smallest number, okay, 0.2, right? Yeah, 0.2. Smallest number that I see here. Okay, who does 0.2 belong to? Belongs to the Belfast jet. Time to schedule Belfast. Where does it occur? Well, this time it occurs in the first column at the first workstation, so to speak, the first phase of work, unloading the jet. That means that that jet, Belfast, goes as far to the front as possible, which first place in the sequence is wide open. Belfast schedule first. Oh, all right, then what? Then mark it off the list. Typically, if you're using Johnson's rule to create a sequence, the sequence often builds itself from the two ends. See, like here, Belfast and Birmingham, in towards the center. All right, well, there's still great big blank space in the center. We keep repeating the process. Of the data that's left, who is the smallest number now? Looks like 0.25, smallest number. Who does that number belong to? That refers to the Manchester jet. It refers to loading the Manchester jet, the second phase of work, the second column. That means that jet, the Manchester jet, goes as far to the back as possible. If it is the second phase of work, you push it to the back. If it's the first phase of work, which it wasn't, you push it to the front. All right, well, Manchester then is all finished. It is scheduled. We know that we're doing it fourth. And then of the survivors here, who is now the smallest number? It looks like it's at 0.3 right here, right? Of the four numbers that survive, belongs to the Dublin jet, is in the first column. Therefore, Dublin, that jet, is pushed as far to the front as possible. Second place is open. Fine, it's scheduled. Mark it off. Well, and then there's only one left, and it's that London flight. There's the Johnson's rule sequence. If you want to unload and load these jets, working on them one at a time, one crew doing the unloading, the other crew taking over and doing the loading, if you want to get all five of them done as soon as possible, do them in this order: Belfast, Dublin, London, Manchester, Birmingham. If you follow that sequence, you will have minimized the make span of the schedule.